In this lecture, we will study how we can insert a node in a linked list. Since we know linked list is a linear collection of data elements are called nodes. Node contains two parts. One part contains the information of the node and the other part contains the link to the next node, or we can say the address of the next node. Here we are seeing that we have the nodes here in the linked list. Start is a variable that contains the address of the first node. This contains a pointer. Second part contains a pointer to the next node. Suppose this node is A and this node is B, and here I have represented a null by a symbol X. Null is representing that this is the end of the linked list, and after that no node is there. Suppose you want to insert a node in this linked list. If this was the case with array, we need to shift the elements downwards to insert an element in the array. But what will we do when we want to insert an element in a linked list? Since in linked list nodes are not arranged in consecutive manner, they are arranged randomly. Wherever the computer finds the free space, that free space will get allocated to this node. So if I want to insert a node n in this linked list, so if we see this by figure, since node A is containing the address of next node B, so we will allocate the space to the node n wherever the space is available, and now the link pointer of node A will point to the address of node n, and the link pointer of node n will point to the address of node B. So in this case, by changing the link pointers of A and node n, we have inserted node n between node A and node B. So node A points to the new node n and node n points to the node B, to which A was previously pointed. So now, from where we get this free memory? This free memory we called it avail. It is a list of free nodes in the memory. It contains unused memory cells, and these memory cells can be used in future. We can say that avail is a list, or avail is a list of free memory cells. Whenever we need space to allocate some element, or to when we need a space to allocate some node, we will take it from the avail list and allocate to the node. So it is also known as list of available space, or free storage list, or free pool. It is used along with linked list. Whenever a new node is to be inserted in the linked list, a free node is taken from the avail list and inserted in the linked list. Similarly, when a node is deleted, means when the memory gets freed, then also that space will get added to the avail list. So it can be used in future. We can see it. Suppose this was the node, this is the data list, and this was the node that we were inserting between A and B. So if we see the memory representation of this node is the part of avail list. We will allocate this the space from this node. Now A is pointing to the first node of the avail list, and the link pointer of this node n is pointing to the node B, and since avail is pointing to the first node in the free storage list, now avail will point to the next node in the free storage list. So in this way we can allocate space to a node from a free storage list. So we can insert node in linked list in different ways. When you want to insert a node in the beginning, at the end, after a given node, or before a given node, or you want to insert a node in between some sorted linked list. So in this lecture we will study how we can insert a node at the beginning of the linked list. So we have an algorithm for this. This algorithm insert item as the first node in the list. Means this algorithm will insert the node at the beginning of the list. Since the beginning of the list is pointed by start. Start is a variable that contains the address of the first node in the linked list. So we need to change the address of the start. So when we are inserting any node in the linked list, so we have to allocate some memory to the node. So from where that memory will come? That memory will come from the avail list. So first of all, we will check if the memory is available in avail list. If it is available, we will allocate it to the node. Otherwise, we will say overflow. Overflow is a condition when we want to insert a node or element in a list, but space is not available. So if avail is equal to null, then we will write overflow, means no memory is available. Otherwise, if memory is available, we will assign the first node of the avail to new, and now avail will point to the next node in the avail list. We will assign the information to this new node, means the info part of this new node will contain item, that value you want to insert in the node, and the link part will contain the address of start. Since we are inserting a node in the beginning, the link pointer of the node will new node will point to the address of start. And now since this new node is the first node in the linked list, so the now address of start will be new, means now start will point to new. That means new is the first node in the linked list. So let's understand with the help of an example. Suppose we have this list. Start is containing the address of the first node in the list. We want to insert a new node in this list. We will allocate memory to this new node from avail and assign the value 9 to this node. Now we will change the link. Now this node is pointing nowhere. The link part of this node is null. So by changing the link part of this node, now this link part will point to start. The link part of this node will point to start, means its link part will point to the first node in the previous linked list. Now since it is added in the beginning of the linked list, so it is the first node, and according to our algorithm, start is a variable that points to the first node in the linked list. Now we will change the address of start to the address of 9. Now start will contain the address of this new node, since it is the first node in the linked list. So this is the way we can insert a new node in the linked list in the beginning. Thank you.